Hello students, welcome to the KSMP Academy. In this video, we are discussing in continuation with the first video on the units and measurements. So here we are going to discuss the system of units. So in the earlier time, three systems were used: MKS, CGS and FPS. Now what is MKS? If you look at, M is the unit of length, K is for mass, that is kg, and it is for time. So meter, kg and second. Meter, kg and second. So this was known as MKS system. Similarly, the second system, as you see, is the CGS. Here again units are of length, that is centimeter, and for mass it is grams, and for time again seconds. So it is CGS system. Then third one, as you can see, is FPS. So it is a different kind of system. Here length is measured in foot, it is pound, and time again in second. So it is known as FPS system. So these three systems were used generally in the earlier system. So every system is having merit and demerits. So in CGS system, many of the derived units can be expressed, but they are very small. However, MKS system gives a convenient size of the derived units. So CGS system is not so much popular in general, but both the systems are used. FPS system rarely is used, it is not very much popular. It is having inconvenient multiples, and some multiples are involved in the conversion, so generally it is not accepted. And in the older days also, the most popular system was MKS system, and then CGS system, and the last one was the FPS system. So these three systems were used earlier for expressing the physical quantities. Now next one is the international system of units, which is very important and which is worldwide accepted. So this is known as SI unit or international system of units, which is, as we are discussing, it is the international system of units, and it is accepted worldwide, and it was developed by the International Bureau of Weight and Measures in 1971 and was reviewed in 2018 in the General Conference on Weights and Measures. Now this system is used now in scientific, technical, industrial and other purposes. So whatever you see nowadays, it is basically SI units. So we will go to the system, we will see the example of the SI units, that how to represent the different physical quantities in this international system of units. So we know there are two kind of units, that is fundamental and derived units. So here in SI systems we will see the fundamental and supplementary units. So as you can see in the table, the fundamental units, you see first one is the mass. So it is represented by capital M and its unit is kg, kilogram. Length is expressed as L, capital L, and its unit is meter. It is again fundamental unit. Time is having unit second, represented by capital T. Temperature is represented by theta and unit is Kelvin. Current is expressed as ampere, and we use capital I to represent the current. Luminescence intensity, unit is candela, CD. As you can see the representation of the unit. Quantity of matter, we all know perhaps, mole. What is mole? That we all know. The quantity of matter is measured in mole. So this is also a fundamental unit. So these are 7 fundamental or basic units, and in SI system we also have 2 supplementary units. So these 2 supplementary units are phase angle and solid angle, and as you can see the units of phase angle is radian, and for solid angle it is steradian. So these are also the two supplementary units which are also considered as fundamental or basic units. Some example of derived units you can see here, that is for force. So we all know force is Newton, and which is also represented as kilogram meter per second square. And this how we can understand, because we know F is ma, so m is kg, and acceleration is meter per second square, so its unit is kilogram meter per second square. So it is derived by the fundamental or basic units. As you can see, kg, meter and second, these are basic units or fundamental units. Similarly, other quantities you can see, for example, if you see the speed is what? Speed is distance upon time. So distance we know is measured in meters, so we can see meter, and per unit time meter per second. So meter per second is the speed, and it is derived by from the fundamental unit, that meter per second. Similarly, other, for example, acceleration, as we have seen. So acceleration is what? Change in velocity per unit time. So per unit time and change in velocity. So unit of velocity or is meter per second. So this is giving us meter per second square. So for acceleration, unit is meter per second square. So it is again a derived unit. Similarly, other we can have a look. Work and energy, these are represented as Newton meter or joule. Again, these are derived units. Power, as you can see, which is represented in watt or Newton meter per second. So power is energy per unit time. So what we look at here, that if we don't remember the derived unit and we remember the formula for that particular physical quantity, so we can have the derived unit. For example, here we have seen for force, that is we are having the formula for the force, which is F equal to ma. M is expressed in mass, acceleration as meter per second square, and which is giving us the derived unit. So that approach we can apply. For some of the quantities we have to remember. It is better if we remember some of the derived units. Otherwise it is very simple. If we know the physical relation of that particular physical quantity, so that can give us the derived unit of that quantity. Now we are coming to the next topic, which is significant figures. These are very important in the measurement, as the significant figures gives the precision of the quantity. That's how precisely a measurement has been done. For example, you see, if a quantity is 1.65 seconds, so it is having 3 significant figures. Similarly, we are having a quantity 287.5 centimeter. It is having 4 significant figures. So by looking at the quantity or measurement, we have to find the number of significant figures. So there are some certain rules. So let us see. First one, that is all the non-zero digits are significant. That is, if we are having example at 2.50, so here non-zero are 2 and 5, so these are significant. If we have a measurement 15 meters, here non-zero values are 1.5, these are significant. If we have 1.05 second, here we have 1.5, these are significant. Of course, we are not discussing the total number of significant figures, we are just discussing the first rule, that is non-zero digits are significant. Now look at the second rule. All the zeros between two non-zero digits are significant. So that means this one, you look at here. So here this 0 is between 1 and 5. So here 0 is also significant. Similarly, other quantities we can have example. Maybe you can have 106 kg. So here 0 is between 1 and 6. So overall this is having 3 significant figures. So 0 is also significant here, as per the second rule. Now let us look at the third rule, that is if we are having a number less than 1, and one example is given here, that is 0.002308. So in this you see total number of significant figures are 4. Total number of significant figures are 4. So number of zeros, if it is having decimal value to the left, that is these 3 zeros, these are not significant. These are not significant in this measurement. So to the left of the first non-zero digits, we are saying the 0 to the left of the first non-zero digit are not significant. So it is having two kind of zeros. One is to the left side, another is in between the non-zero values. So that's how we are having total 4 significant figures in this number. Now trailing zeros are not significant if number is expressed without a decimal point. So let us look at here. This is 1, 2, 3 meter, no decimal point. It is also no decimal, no decimal. So if this kind of value you see, then these zeros, that is 2 zeros here, 3 zeros here, these are not significant. So in all these 3 values, what we look at is significant numbers are 1, 2 and 3. That is total 3 significant numbers we have here. Only 3 significant numbers we have in this expression. Next rule is for trailing zeros. So if we are having a number with the decimal point, then the trailing zeros to the right hand side, that is, look at here, these are 2 zeros to the right hand side. Also these are 2 zeros to the right hand side. So these are significant. So here what we have, we are having 4 significant figures. Let us look at here. Here we have again 4 significant figures, and zeros to the left are not significant. Now if you look at these rules, sometimes we may get confused. So best way to determine the significant figures is to write the given number in the scientific notation, that is in this form, a into 10 to the power b. So if we have this, then perhaps it is easy to identify the significant figures, significant numbers in the given value. For example, we have a measured value of length 1500 meter. Now this 1500 meter can be expressed in different ways. One is 1.500 into 10 to the power 2 centimeter, or 1.500 into 10 to the power 3 millimeter, or 1.500 into 10 to the power minus 3. So we have, this is km basically, this is kilometer. So in different ways we can represent. So in scientific notation we are representing the number. So now in this system we have to look at only this value. We have to forget the powers of 10. These are not having values in terms to the significant figure. So we have to ignore. We have to ignore this. So if you look at in all the expressions here, it is 1.500, it is 1.500. So in all these we are having 4 significant figures. So we are having 4 significant figures. So it gives a simpler way, that is here we have to look only at this multiple, that is if number is a into 10 to the power b, then we have to look only at it. And it is the convention that this number should be written like this, that is 1.500 into 2 maybe, or 3.48 into 10 to the power minus 3 maybe. That is, decimal point should be after the first digit. This should be the place of decimal number. Then we will be able to write the significant figures properly. So that is the best way amongst all to identify the significant figures in a given expression. Zeros, it is very important, which are conventionally put on the left hand side of the decimal point. These are not significant. That is, for example, this 0 we have put, but it is not significant in this expression, that is 0.125. So based on this we can find the significant figures if we are having a measurement value or measured value, and we have done a measurement, then with the help of significant numbers we can find the precision of the measurement. That is the relevance of finding out the significant numbers. So thank you students, thank you very much, thank you for being with us.